All right, here's our 10th problem. This one involves a performance chart for fuel consumption. So essentially what this chart's going to give us is how much fuel is being consumed by a particular aircraft given the RPM of the engine. So we're going to be given the RPM, then we're going to be able to figure out the brake horsepower, and with the brake horsepower, we're going to figure out how much fuel it's consuming. So we have over here our specific fuel consumption. So this is probably the chart that people have the most issues with, but if you just kind of take it simply, or take it just in steps, it should be easy. So the most difficult part is right here, the specific fuel consumption. It's in pounds per brake horsepower per hour. So if you just take the very first unit you run into when you're reading it this way, put pounds, and it's going to be over brake horsepower times hours. If you can do that, it makes the problem a lot easier. So that does work out. It's really going to be pounds over brake horsepower per hour, and that being the case, this brake horsepower would drop down. That's where this is coming from if you're like just doing the algebra portion of it. But if you can just do that, then you'll know, it'll make this problem a lot easier. So we do know in this case, let's just read the problem first. It says, determine how much fuel would be required for a 30-minute reserve operating at 2,500 RPM. So what we're trying to figure out is how much fuel, and the answer needs to be in pounds, we would need. So for every flight, you do have to have a 30-minute reserve of fuel per the regulations. So we're just trying to calculate how much fuel that actually is. All right, so again, we are going to take our RPM. So let's just work through the problem, and then we'll come back and talk about it a little bit. So we go to our RPM 24, here's 26, therefore this is going to be 25. So we'd go up until we hit this red line. So we're only going to use the red curves here. That is, the red curves are like our normal cruising speeds. If I wanted a full throttle operation, I would use this upper brown curve and this lower green curve. But we're just doing a normal cruise speed. So I need this intersection here. And I'm going to go ahead and just take it all the way up until I hit this intersection. So I need both of these numbers. So right here on this lower intersection, I'm going to come across, make it as straight as you can, and I'm going to pick this value. So I have in between 0.45 and 0.5. So it would be nice if this was divided up. It would make it a little easier, but we're going to have to make a choice of what our number is right there. And then on the top intersection, we're going to grab this number as well. So we're going to also just have to make a decision on that. That's what makes reading this chart more difficult than other charts. But okay, so let's go ahead and grab our first number, our specific fuel consumption, right? So we're going to say, let's just say for 6, 7, 8, 9, 10. Let's just say we are at 0.49. 0.49, and the units of that is pounds brake horsepower per hour, right? So we know that we want to have our answer in pounds. So the only thing left in this set of units right here is going to be pounds. So therefore, I'm going to need to multiply by brake horsepower and by hours to get rid of those units. So we need to come over here and get our brake horsepower. So we are somewhere between 140 and 150. I'm going to go ahead and just say 143. So we'd have 143 brake horsepower. So brake horsepower and brake horsepower are now canceled. So we need to get rid of one more thing. We need to get rid of our hours. It does tell us that we're operating for 30 minutes. So we're going to have to convert that 30 minutes to hours. So I'm just going to go 0.5 hours, and then hours and hours are going to cancel each other. And I'll be left with the unit that I want, which is pounds. So we take that and just multiply these three numbers together. Times 143 times 0.5. And we would come to an answer of 35.035, or we could just say 35 pounds. So we would need 35 extra pounds of fuel for this 30-minute reserve. So again, the steps are, you're going to go to your RPM. You're just going to go up until you hit the red curve. The red curves are our normal cruise speed. We're going to go across, get our specific fuel consumption, and then we're going to go up until we hit our second red curve, and we're going to grab our brake horsepower over here. Once we have those, we're essentially just going to be multiplying them together, right? We're going to multiply our specific fuel consumption times our brake horsepower, and in this case we are going to multiply by the time to get the pounds of fuel needed for our reserve.